Where's Wavy? This is his voice band. Hi, Wavy.
Hey, Kerry.
How are you? You good?
Kerry, can you hear me?
Yeah. Can you hear me? Can you hear me, Dave?
Yeah.
Okay,
I'm
cool.
here. Can you got me?
Yeah, perfect. Can I admit everyone?
Yep, go for it.
Okay, awesome. There's a whole lot.
Maybe tomorrow, are you going to the office, but you'll be back in the afternoon.
Oh, good evening, everybody.
Evening all. Oh, I see I was muted. Good evening, all.
Good evening.
How are we doing? More people coming still?
Oh, we're at 30. We're at 37. There should be 100. So I mean, it's up to you.
Give it a couple
There's
of minutes.
120 emails that go out every week inviting everybody. So
I get the odd WhatsApp or something to say can't make it or stuck at work or things like that. So people do have lives as well.
copy.
Yes. You want to go home?
I'm dedicated.
Most of us, not everybody. Only some of us.
Okay, give it another minute and then we'll start.
Yeah, awesome.
Maybe do we have to print out that thing? I can't. My color printer's gone on the blink.
Well, then you just won't be able to do the exercise.
Can't do it on the screen with your head, can you?
You might find it a bit awkward. There is a reason the email went out, Alan.
Let's try something. Yeah, okay.
Okay. I'm going to share a screen. We can get going. We'll see that, Kerry. All good? Okay, perfect. Yeah, now I can see it as well. Okay. Session 7, tidal theory and tidal streams. So we'll run through tidal definitions, levels, and datum. We'll go through a bit of tide tables. And then the use of the Admiralty method. As I said the other day, the Admiralty method is probably the most commonly used for standard port and awareness for secondary ports. Okay. And then the use of tidal diamonds and tidal streams from atlases for chart work. So, tides, basic ideas. Tides are the rise and fall of sea level caused by the confined effects of gravitational forces exerted by the moon and the sun on the planet Earth. I don't think this is strange to anybody. So if we look at the picture on the right, and 6 hours later, the same spot. So tides can be used for a given locale, and you'll find that their range or amplitude is what we call the tidal range, okay? So for any given place on the planet, we can actually get tide times and amplitude predicted, okay? Please remember, guys, however, these are only predictions. Actual tidal height is affected by all sorts of other things, wind and atmospheric pressure. So we've all seen those horrible photographs and pieces of footage where, you know, a hurricane makes landfall, and at high tide, the sea just starts breaking over the walls and things. That's simply because of very, very low air pressure and very big high wind effects. So there are only predictions. So always give yourself a bit of range there. Okay. Where we look at the things, okay, the solar picture. Lunar tide is the pull of the moon on the water. So that's the lunar tide, okay? Solar tide is obviously then the sun, and the two combined create our full tidal effect, okay? when the moon and the sun are in line with each other, which happens at times when the full moon or new moon, they're in line. So there's your full moon, there's your new moon, and they're in line with each other. They create springs. And then inversely, when they're not in line with each other, they create neap tides. And then as it goes round, it gets higher and higher and lower and lower and higher and higher. So that's how your springs work. So it's both the pull of both the moon and the sun together, whether it's either side of the earth or both in line with each other, is your springs, and your neaps is when the moon's pulling one way and the sun's pulling the other. Very basic, pretty standard stuff. Okay, so there's a new moon or a full moon about every 2 weeks. It's not quite, but it's about every 2 weeks. So this is how often we either see a neap or a spring tide. So it's more often than waiting for a full moon every time. Okay, pull of the sun and the moon, as the earth rotates, then moves the water from one place to the next. So the pull of the sun and the moon is pulling the water off to one side, and then as the earth rotates, it moves the tide in and out. So the different types of tide that are moving in and out. Now we just use it, okay, tide comes in and goes out twice a day. It's not the same the world over. Many shorelines, like us for instance, we have a semi-diurnal tide, and it's most of the world you see in red here. That's semi-diurnal. That's 2 nearly equal highs and lows each day. Okay. Then in the yellow areas, that's a diurnal tide. They only have 1 high and low each day. There's only 1 high and low each day. And in the blue areas, I couldn't quite get the blue right there, that's called a mixed tide. Okay. 2 uneven in magnitudes of tides a day. I mean, so they can have a very high and then a low, and then it can be a completely different times and when the tide is affected there. So don't assume the world has the same tides, 2 highs, 2 lows every 24 hours. They don't. So you need to know what part of the world you're in. Okay, the chart datum, we've spoken about this, is the water level at the depths, okay, at your lowest astronomical tide. Remember we spoke about this the other day? Okay, it's your lowest astronomical tide. It's the lowest tide they've ever recorded is what they put the chart datum on. Okay, i.e. in the non-tidal areas, there obviously isn't a lowest astronomical tide, so they use the mean sea level, the average sea level for chart datum. But then tide doesn't affect you, so you can always have pretty much the same depth all the time. Okay, so if we look at the chart definitions, as it were, okay, so hat, that's our highest astronomical tide. The same as our chart datum is our lat, lowest astronomical tide. Hat. Okay, mean high water spring. So that's your average high water spring tide. Okay, now these are quite important because if you're trying to look at the height of the lighthouse, that's measured from your mean high water spring level, whereas your underside of a bridge is measured from a hat level. So if you're trying to clear a bridge with a mast, make sure you calculate it from hat, the water below hat. Okay, mean low water springs, well, that speaks for itself. That'll give you your spring tide range. And then chart datum, that's your lowest possible depth you've got, lowest astronomical tide. Okay, your drying height, that is an area where at high tide, there's land that's covered, and then when the tide goes out, a piece of land appears. Okay, it doesn't always have to happen every time. Your drying height might be just above your lowest astronomical tide, and it only appears every now and then, but that's a drying height. So your depth, when you calculate here, you're sitting on your boat, your depth is calculated by your charted depth. That's the charted depth below your chart datum, plus your height of tide. That will give you your depth. Or it'd be the reverse. it'll be your height of tide less your drying height. We'll give you, so if you put your boats over here, you want your depth, your height of tide less the drying height will give you actual water depth. And why do we need to know our depth? Well, for many obvious reasons, we need to know what our depth is. Anchoring, knowing where we can make passage, knowing we can get under a bridge. There's 100 different reasons we need to know our depth. So let's try and do a little quick question here. Your depth gauge reads 3.2 meters at low tide. If you want 4 times depth of chain, so you've got your chain and you want to throw an anchor out, so you want 4 times depth of chain, how much would you need to put out if your tide table says? So high water, 1703, 4 meters. Low water, 2340, 1.2 meters. And your charted depth is 2 meters. Okay. So how much chain would you need to put out? Just working on that. That's assuming you're going to spend the night on anchor. So you will have a low water and a high water. So your tidal range, 2.8 meters. That's the difference between your 4 meters and your 1.2. That's how much the water will go up and down in that tide. Your charted depth is 2 meters, that you know from your chart. So your maximum depth at any time is going to be 4.8 meters. Make sense? So it's your tidal range plus your charted depth gives you your maximum depth. Therefore, times it out, you want 4 lengths of chain, we call it 20 meters. So there's a very real reason for wanting to see what your depth is going to be when the tide either comes in or goes out. Okay. You want to anchor overnight when the tide will go in and out. Your draft is 3.5 meters, therefore 4 meters minimum, so you've got a little bit under the boat. Okay. You've got your high water at 1843, 6.1 meters, low water at 0040, 1 meter. How deep must the water be when I'm anchoring? At 1840. So we know we're anchoring at high water. So we need to look at our range. What's it going to be at midnight? So we want 4 meters minimum underneath, 1 meter low water tide plus 3 meters of charted depth. There's our 1 meter low plus 4 meters. Tidal range, 5.1 meters. So that's how much it'll drop. So we'll want 5.1 plus 3 meters, 8.1, plus 1 meter for our tide. Gives us 9.1 meters that we will want in the end. That means when the water drops 5.1 meters, it still leaves you, sorry, I've got a 3 there, it should be a 4 meters of water. Tidal streams. Okay, so the tide doesn't just go in and out, it flows in and out. Okay, and some of them can be very, very quick. This is a Alamy shot that I found, it's rather nice. So tidal streams is the speed and the angle at which the tide comes in and out. Okay, here's a shot of the Severn Bore. It's the Severn River, that's the tide coming in. And the guys actually surf it, it comes in so fast. Okay, So that's tidal streams. What is the effect of wind on our tide? Now, this obviously affects us as sailors enormously. Okay. When we've got wind against tide, it makes the sea very, very lumpy and bumpy, and it's not very nice at all. Okay. When we got wind with the tide, it makes it very calm and flat, even flatter than normal conditions would have. So it's lovely sailing in that. And then you've got, okay, where there is strong tide being funneled through a gap or around a headland, you've got something called the overfalls. That's where tide is actually creating its own current or river. And we see that very, very easily if you stand by the edge of a normal river and you watch it while the water flows around a rock just on a river. That's actually an overfalls. Okay, in a river they call it rapids, at sea we call it overfalls. This is one that was taken, this is just off the Needles in southern England, and you can see on the picture here how distinct that overfall triangle is where it comes out of the Solent. Water's calm there, and then you go into the ocean breeze, and it's very calm here inside, but just at that point of entrance, there's a massive overfalls there, and you can see how big the waves are from that yacht. That's sort of 30, 40-foot yacht, and it's just disappearing into those waves. So overfalls can be quite nasty. They're usually marked on a chart by waves, and they tend to be avoided at all costs. Okay, tide tables. Okay, now we've spoken about the tides and sort of thing. Where and what do they come from? Okay. The publication, which is given, we use tide tables, is the high water and low water times of each day for a standard port or a place. Okay. They'll quite often give you lunar information, so you have an idea of where you are with the springs or neaps. Okay. But they just give you a place, sunrise, sunset, high tide, low tide, moonrise, moonset, okay? Ports. Now that's obviously a tide table comes through specific ports. And there's two categories of ports. The first one is a standard port where the tide is actually measured, recorded, and they have hourly information from a standard port. Secondary ports are where the tide is not recorded. And you have to work an estimation with that. Whoops. Okay. So your standard ports have tide times printed for them. So all major sort of ports, cities, the likes of Cape Town, but you won't find tidal information terribly easily for small ports. Okay. I don't know if there is tidal information for Hout Bay, for instance, but I know in the south coast of England, you can go from Portsmouth and then you want to go to Ryde and there's no tidal information. It's a secondary port. Okay, you have to then work it out. Okay, standard ports have tides printed specifically for that port, so you can just look at it. This is Portsmouth Harbour for January last year. Okay, it's obviously useless information now because it changes every year. Please don't use outdated tide tables. You can get yourself in all sorts of trouble and look really stupid. Okay, we just have to look at the day and we can check the high water and low water depths and times, and that's it. We know exactly what the tide's doing for that port. It's nice and easy. Okay, but don't forget, if you're looking at tidal heights, you must also add your chart datum or subtract your drying heights. Okay, big mistake. Oh, we've got 4.7 meters of water, but you've got a drying height of 1 and you won't make it. Okay, so if we look at, this is Portsmouth Harbour, and I just happen to be using Portsmouth for these. At high water, tide comes in, and this entire drying area here is green. Disappears underwater, this entire area. So if you're coming out of Port Solent here, at low tide, you literally have to follow that channel. At high water, if you've got a draft of anything less than 4 meters, you can just sail straight across and out. Okay, so at low water, you can't go anywhere near there because it literally dries. And then these blue sections where it's slightly shallower, You might not make it. So your navigation up into Port Solent has to be pretty accurate, and you must know what your tidal information is. Further down here in the marinas by the mouth of the harbor, they've pretty much got water all the time. Okay? And obviously in the white section, which is deep enough, that's the main shipping harbor, you can get through it. So your tidal information is actually quite important when you're entering and exiting ports themselves. The tidal curves, okay? This is the tidal curve for Portsmouth. It's the one I asked you to print out. This displays how the tide rises and falls. Okay, so this is the daily average for mean springs is the red line, and the blue dotted line, where it comes off the red line, is your Neaps curve. Okay, so that is how the tide comes in and out in Portsmouth. You'll notice it takes 7 hours to come in and 5 hours to go out. So it floods out a lot quicker than it floods in. Okay. How they work. How do we use a tidal curve? You collect your high water and low water for the period that you want to be looking at. So in this case, we've just gone 12:30, 12:03, 4 meters, and then 17:50, 1.2 meters low water. And we mark that off on our tidal curve. Okay, so have a look here. We've got 1.2 meters low water at the bottom, and we've got 1, 2, 3, 4 meters marked off at the top, and we draw a line at an angle across like that. Okay, so there's a low water and high water depths for this day time that we're looking at. Okay, we then put a high water time in the middle there, 12:03. We can put it in those boxes down the bottom here, and then we go an hour before and an hour ahead of each of them. So that fills in our time around that high water. Okay. Mark your time, say 13:30. So there's 13:30. We put a line up there. Where it crosses the tidal curve, we draw a line across. We make sure we go across our original tidal line, and that will give you your depth of tide at that time. So where it intersects doesn't necessarily, I mean, you can do it from here if you want and then come across, and then it'll give you a completely different reading. Okay, that just happened to use 13:30 on that one. Okay, and remember again, that only gives you your tidal height. It doesn't give you your depth as well. You need then to add your charted depth or drying height. Take away your drying height. Okay, so if we want, say we need 2 meters of tide, and we do the same thing, there's our first line, same tide. Okay, we want 2 meters. So we take our 2 meter line. There's our 2 meter tide. That's how much water we want. We take that across our tidal curve, and where it meets our tidal curve, I'm doing this at mean spring high. Okay, so that goes down there and down there, which means it gives us a time 17:15 to 07:15 to about just before 4 o'clock, 1600, 15:55, 15:50. That means that we have 2 meters between that time and that time. And so if you need 2 meters of tide to get out of a port, there you go. You can leave just after half past or 7 o'clock. Remember, give yourself a little bit of time. So say leave at 7:30, come in at 3:30, and you'll have enough water to be able to get in and out of that port, assuming you needed 2 meters of tide. Okay. Secondary ports, on the other hand, don't have a nice tidal curve like that. They don't have one made up. Nobody's recorded the tide going in and out. You just don't know it. Okay. So you get one of these sort of things. It's in your in your secondary port information. Okay, it references a standard port. Okay, so you're using that tidal curve, and then you adjust it accordingly with this information. Now, we're not going to go into all that depth at this stage. Okay, let's give it a go though. If
Sorry,
this
Wavy.
is yeah,
There's a question that Heidi Berger raised before you do another questionnaire.
yeah.
So for the first tide question, shouldn't the length of chain be 24 meters? There's a 2 meters of charted depth, and at high tide is at 4 meters. So you have a depth of 6, and 4 times 6 of chain is 24 meters. Correct me if I'm wrong, please.
I can't remember the numbers off the top of my head.
Sorry, before you ask another question and confuse everybody. Or
Yeah,
her.
I'll have to go back to that. Okay, let's go right back.
Sorry.
Hang on. No problems. Where was it? 2.8 meters plus 1.2, so your maximum depth is 4.8. 5 is 20 meters. No, that makes sense. I mean, this makes sense to me. So your maximum depth would be 4.8 meters, and you want that at 4 times, so 5 4s are 20. Sorry, I'm not following how if you got 24. And we can talk about it afterwards.
Okay, thanks.
I think what might have been done is there was total tide taken and not the tidal range, which would have given you extra 4 meters. So total height is 4 meters, but your tidal range is what you calculated on. Okay, so where were we? Okay, so give it a go. High tide's at 12:03, and it's 4 meters, and low tide is 1750, and it is at 1.2 meters. So actually the 1750 is an irrelevant number. It's the low water that you want here and your high water up here. What is your depth at about 810? Who can I see on video? Somebody just speak up when you think you've had enough time. It's not a difficult one, but that is the standard Admiralty tidal curve, and that's how they work for pretty much all ports that the Admiralty record tide for. It includes Cape Town as well, by the way. You can get an Admiralty tidal curve for here.
David, is the stream coming in, stream going out at the same rate?
No, the actual
Oh,
curve
sorry.
gives you the rate of flow. So the
Right.
curve tells us here, so it comes in a little bit, then it slows down a bit, and then it accelerates again, slows down a little bit as it comes out, and then flows out again. You'll note that in Portsmouth, it takes 7 hours to come in and 5 hours to go out. So although the tide goes through in those 12 hours, it takes longer for it to fill than it does to drain out. We'll talk about streams in a minute, but this is just depths that we're talking about at the moment.
Okay, so are we talking about spring, right? Fine.
And we're using the spring, yes, use the red curve. That's the one I've just been using. It's just easier, I think, on the presentation to see it. getting some answers here. So most of them are coming in around just over 2. So basically what you should have something that looks like this when you're finished. Okay, there was your low water tide, there was your high water tide. Okay, we wanted what was it, 8:30? So we came up at 8:30, where it crosses the tidal curve, comes down. So I get 2.1, 2.2, something like that. So that's kind of what we should be looking at from the tidal curve. Remember taking it, there's your low water, there's your 1.2, given 1.2 from your tide table. There's your 4 meters, also from your tide table. That gives you your angle. Okay. There's our time. We put our 12:03 in there and worked it backwards to 8:30. Okay. 8:30 we come up, we hit the tidal curve, and where those two cross, we come down or go up, doesn't make any difference, and we get our depth. So 2.1, 2.2, something like that would have been the correct answer. And I think we're getting pretty much, looking at them, they're pretty much all around the 2s. So that's a promising thing. Okay, so if we look at another little question using the same chart, if we need 3 meters of tide, what times can I sail? So that's looking at the tidal graph the other way around. The one was telling me from the time that I knew to depth. This is now from the depth that I want to time. We start exactly the same way. We put our low water in on the bottom graph and the high water in at the top. Hopefully that's not an answer. He writes to everybody, it's deep enough. 940 to 1503. Okay, so your tidal graph should look something like this. If you'll notice, I've got my 3 meter just slightly moved this side because that's just where the PowerPoint presentation clicked on it. I couldn't get it on the 3 meter mark. I apologize for that. But same as before, there's our high water, there's our low water. We wanted 3 meters, so we come up there, take it across the tidal curve and drop down. There's our times. So mine is ever so slightly out. It should be slightly higher because of, unfortunately, where the PowerPoint presentation allowed me to click. So from 9:30, 9:45 to about 1500, you should have deep enough water. So that's kind of what your tidal curve should have looked like. Okay. Diamonds, tidal diamonds. You see these chaps on a chart. They're called a tidal diamond. Okay, it'll have a diamond around it with a letter inside it. Okay, that is what a tidal diamond looks like on a chart. Okay, that relates to this table that will be on the chart as well. This big table that I'm pointing at there. Okay, what that table gives you is from a specific standard port. Okay, it'll give you the degrees, angle, and speed of flow, okay, of the tide at that geographical position. There's your tidal diamond A, which will be on the chart at that geographical position, okay? So at high water, from a specific standard port, okay, it will give you, so if the time at high water is, say, 1700, at 1700, the tidal flow will be 171 degrees, at spring tide 1.1 knots, low neap tides 0.5 of a knot at that geographical position. Okay, so it references it 6 hours before and after. Okay, so as I was saying, at high water, that will be the angle of flow 171 degrees at 1.1 knots at spring, or at 0.5 at low, okay, at that specific position on the chart, okay. The same diamond will be showing on charts. It doesn't matter which chart it's on. If, for instance, this is high water springs at Victoria, okay, that position will be on all the charts that have tidal diamonds, that information. It'll make no difference the scale of the chart. And if you remember when we went right back in the beginning and we did the course over ground, course to steer things, okay, that is where our information comes from. That 3-arrowed one. So that's your tide. That's the speed and angle of the tidal flow. And that's where that information comes from. So this is how we calculate it. And if you remember the one, this is the one we arc off. So that's the course we want to do. We want to go from A to B. We have to take into account our tide. So what's going to happen to our boat as we sail? So that's our course to steer. So we will be sailing at a funny angle to go straight the whole way. So that's where this information comes from. So what will the tide be 4 hours after high water neaps on tidal diamond A? So then we'd look at it and go, okay, 4 hours after, okay, there we go. After high water, 1, 2, 3, 4 hours, it will be 113 degrees at 1.2 knots, let's say it neaps, so that's 1.2. Okay, that will be what influences the boat at that time, at that geographical spot. Okay, you can also get streams from tidal atlases. So this is exactly the same information, but instead of being isolated diamonds stuck around the chart, this is literally the streams flowing out of an area. Okay, so you can see in this particular area, the tide is now flowing gently around there, and as it comes between this headland, you can see how it speeds up. Okay, that gives you the flow and direction exactly the same way. So, okay, it's based exactly the same thing. You'll have 6 pages, 6 before, 6 after high water, and it gives you direction of flow, and it gives you the speed, and that's both for springs and for neaps. So that's exactly the same information as a tidal diamond, it's just more detailed. Okay, so little diamond quiz. Is the information of a tidal diamond, tidal stream atlas, and the same as a tidal diamonds? Well, I've just answered that question, but okay. When creating a course to steer, can you use tidal diamonds and tidal atlases? Could you reference both? Okay, so no or yes, depends on the chart, have no idea. So, is the tidal information the same on tidal diamonds? Yes, it's identical. If you put that geographical tidal diamond onto the tidal stream atlases, the two should match identically. Okay. When creating a course to steer, can I use different diamonds? Yes. Remember the tide changes from hour to hour. So use as many diamonds as you need to if you're moving across tidal diamonds during that hour. So you go from one diamond to the next, or you go from one section of your stream atlas to the next, because it changes from hour to hour. Okay. And can I use, when creating a course to steer, can I use tidal diamonds and tidal atlases? Yes, with pleasure. But remember, your tidal atlas is more detailed. I'm just going to go backwards quickly, just to show you that. Your diamond gives you a total hour for one geographical point. So if we go back to the beginning of diamonds, the whole tide is based on that one geographical point. Okay. If we look at the stream for an hour, it gives me a much bigger, broader picture of what's happening to that tide. It's not one tiny little geographical point that you're looking at tide for. So stream atlases tend to be a lot better to use. The only problem with them is, if you want to know what that angle is, you've actually got to measure it. So this is based like a chart. There you can see your degrees. North is up. You would measure that angle practically with a Portland plotter or a parallel rule. Okay, so good timing, 15 minutes. Again, we just sort of scratched the surface there of tides. There's a hell of a lot more to it, secondary port calculations, etc. If you're thinking of doing all your exams, you do loads and loads of examples in the classroom. They are guaranteed to be in the written and the practical exam. You'll be expected to perform them at sea as well. What is the tide around Cape Point this afternoon, sort of thing. You'll also need to get tides right for passage plans. Now, when you're doing your exams, your passage plans, you'll be asked to do passage plans around a place, and those passage plans require tidal information. Okay, and practice with these things. Practice makes perfect. If you've got any queries, there's my name, numbers, give me a shout. Most of you see me at the club reasonably regularly. So next week, visual aids to navigation, lighthouses, beacons, light characteristics, that sort of thing. So these are things that you'll actually see at sea. And then some meteorology, just the basis of meteorology, the knowledge of terms, shipping forecasts, Beaufort scale, and some basic knowledge about highs and lows and fronts. So you can have a look out the window, hopefully, and have a little bit of a better option. Okay, so good. 1:45, 15 minutes question time. I was looking at your numbers there, Heidi. And I think what the calculation was, you took the depth of the tide, and you didn't take out the 1.2 meter at the bottom. So you took the whole tide, and then you added your chart datum. It's the tidal difference that you're working out. Any questions, guys? There's usually one or two with this particular lot. Has anybody sailed in tidal waters quite heavily?
Hi, David. It's Heidi. I just want to go to the tidal question quick. I think I'm probably just misunderstanding something. If you're wanting to work out your chain depth, surely it'd be the full depth of water that you'd multiply your chain times 4 by. So like the maximum possible depth that you'd have the whole time. Is that right?
That would be what you'd want to do, yeah. So you'd work out what's going to be, how much water is below me all the time. So what's your chart datum, okay, plus your tide, the lowest tide, plus your tidal difference, okay, because you're not necessarily going to be there at high tide. So you work it out, low tide plus chart datum plus whatever the range is for your period there. Make sense?
Yeah, I think so. Is that this? But would that just be the same as, is the high water depth at 4 meters, is that measured from the chart datum?
Yeah, but you're not
Okay, so
necessarily.
your high tide depth would be the 2 meter charted depth plus the 4 meter high tide.
That will be your highest depth possible, yeah. So you can get it the same way. You can add your chart datum plus your low water plus your tidal range will give you the same amount. So if you look at the tidals, the Portsmouth chart that we just used now, the stream, you would then go, okay, chart datum of tide at that period will be X amount, plus your chart datum or minus your drying height.
Yeah. Okay, so your deepest part at high tide for that time would be 2 meters plus 4 meters. So it'd be 6 meters.
I can't remember the numbers off the top of my head, but yes, you take your chart datum plus your highest possible tide.
Okay, so that's 6 meters then times 4 to get your total chain length.
That makes sense. I'm not sure. Either I made an error there, which is quite possible, or I did something. The question I'd phrase slightly differently, because when I looked at it now, the numbers made sense to me when I went back to it. So maybe I'm getting slightly off where I'd asked for what I'd asked for, but it was basically trying to get across, take your chart depth plus your tide, whatever tide you're in or going to be in, as your depth, not just read the chart and go, okay, there's 5 meters. You've actually got to take that tide into account. And then obviously you've got to calculate and say, okay, if my boat has got a 4 meter draft or a 2 meter draft or whatever, take that into account. But yeah, your depth, your charted depth plus your tide gives you your actual depth.
Yeah, okay, that makes sense.
Or your drying height less your tide.
Yeah, yeah.
So in places where it dries, obviously, you've got to take the one from the other rather than adding the two together.
Yeah, that makes sense. Cool, thank you.
Oh, no worries.
Question. The tidal curve has got a factors up to 1, 0 to 1, and the Portsmouth curve. Could you just remind me what those factors help us with, or why they're there?
The factors, sorry, I'm not following it. Let me just have a look there, sorry. I'm just going to go back and look at the curve. Okay.
Go from 0.1
So yes,
to
that's
2,
basically between so 0.0 is tide and 1 is the highest possible tide, and that's the factor of the tide broken up into 10% basically.
Okay, thank you.
So that's just a factor is say 4, so we're going to get 40% tide. It's an easy, quick way of being able to talk about it. You're at 0.5 of the tide. That's the factor of the tide.
Okay.
So you could literally turn around if you're going to taking somebody's boat out of portfolio that we're talking about, you can say you're going to need 0.2 of a tide all the time. That's the factor of the tide for that particular port, say for that boat. As I said, we are just literally scratching the surface of tides here. We didn't even go into secondary ports at all. And obviously you've got to then take the same calculations for a secondary port and then do additional calculations to get tide, because you haven't got that nice tidal curve for that tide, for that port. Tides tends to be one of those things, especially for guys that like us, we sail in pretty much non-tidal water. It's not particularly heavy our tide. It does influence us a little bit, but if you sail in places where there's a lot of tide, we were doing a race once between Alderney, the island of Alderney in the Channel Islands, and the mainland France, and we had 8 knots of tide. So we were actually sailing at about 6.5 knots on a beat, and it was quicker for us to actually anchor, wait the tide out, and then keep racing afterwards, which is not fun. If you get your tide wrong, you're going to stop. In Weestrum, if you get your tide wrong, you don't get out of the harbour. The water literally drops to about 1 meter. So you can't get in and out of that harbour, the yacht basin, until about a factor of about 0.5 on the tide, until it's about half in. Consequently, the marina's got a whole bunch of swing moorings outside in slightly deeper water, so you can sit and wait on one of those. Any other queries? So if you look at the SAS chart of Cape Peninsula, it's Table Bay, False Bay, you will actually see that the SAS chart does have tidal diamonds on it. And that's specifically produced for the South African exams, whether you're doing it through SAS or you're doing it through SAMHSA. They produce, the South African Navy produced that chart with tidal diamonds. So there are tidal diamond charts available for the Cape area. You just have to know what the high and low water is. If you've got a chart world, you can actually order tidal diamond charts. Any other queries? It's been very quiet tonight. Did most of you print it off and try and do the tidal diamonds, by the way? Because I never actually know whether you could, I'm literally looking at a screen, and I got no idea whether people are actually taking note of what I'm actually doing or saying. So it's kind of, I see a couple of pieces of paper being held up. Nice. Colin, thank you. Francis, thank you. There's a couple of people with title screens. That's nice. So it means that hopefully the guys learned a bit today. Yeah. Tides aren't the most exciting topic, I'm afraid. I mean, understanding that, yes, the sun and the moon pull the water, we could go into centrifugal and pyrolysis and everything else that creates the way the tide sort of squeezes out both sides of the world. But again, it's just getting into too much depth for 45 minutes and then 15 minutes of chatting, you know, so it's kind of, there's a lot more to the topics.
Dave, it's suggested reading at this stage on this?
Quite honestly, I find overall books for tide better, like overall books for sailing better. If you can find a good overall sort of yacht master book, there'll be quite a lot of tidal information in there. I do, you know, there are a couple of them on the Arway website that you can order, things like that, that are pretty good. Try and get the more modern ones. Some of the older second-hand ones have got some very, very outdated methods of calculation. With the outdated methods of calculation, you find that you can't actually get the way those tides were calculated originally. So Tom Cunliffe's book is pretty good. He keeps it up to date. He's got a, you know, it's called Complete Yacht Master by Tom Cunliffe. But there'll be a volume, I think he's on volume 9 already now. And so you just keep it up to date. He keeps it up to date with modern navigation, and that includes things like the development in electronic navigation.
Thanks.
Okay. Kerry? Is she there?
That I am.
Yeah, you are. Should we call it an evening then? You can go home. There's no other queries.
Your Alan's gone, so we can.
Coming.
Thanks, Wavy.
Too much of a trying one. Tides is not very exciting. Okay, guys. See you at our club on the weekend, if not before. Cheers. Kerry, thanks for waiting up again.
Pleasure. See you next. I'll see you on the weekend.
Yeah.
Okay.
Cheers.
Cheers. Bye.